6.3 intersection of a straight line and a circle. We are talking about intersection, then a straight line and a circle. Straight line and a circle intersection. But we know that intersection of two lines. If this is y equal 3x plus 4 and this is y equal 2x minus 2, then if we need to find this intersection point, we solve those two equations simultaneously and find the coordinate. Now only difference is now assume this is this equation is y equal x plus 5 and assume this one is x square plus y minus 2 square equal 29. Now we have to, those are the two intersection points. Now we have to solve those two equations and find the intersection point. So we'll work out this one. Now we have x square plus y minus 2 square equal 29 and y equal x plus 5. Then x square plus I'm going to solve simultaneously y. Now I know what is y. Y is x plus 5. X plus 5 and minus 2 square equal 29. X square plus x plus 3 plus 5 minus 2 plus 3 square equal 29. X square plus x square plus 6x plus 9 equal 29. So 2x square plus 6x minus 20 equal 0. So I'll divide by 2 both sides. So x square plus 3x minus 10 equal 0. So I can solve this one. X plus 5 and x minus 2 equal 0. X equal minus 5 and x equal 2. Now I have two answers. One is minus 5, another one is 2 for x value. Now I want to find the relevant y value. When x equal minus 5, y equal minus 5 plus 5 from here, which is 0. Then when x equal 2, from this equation y equal 2 plus 5, which is 7. So we found out the intersection point. Now what will happen? A circle one option is it make two intersection point. Other one is it will touch on the circle at only one point, or it doesn't intersect at all. So how are we going to distinguish these three? Yeah, we can look at like this. Now we can see that this is a quadratic equation. We have two solutions. It means it is intersect two places. Assume that a quadratic equation you have, and it has a one repeated root, one root. It means it will touch. And assume that okay, to have two roots, b square minus 4ac greater than 0 for this quadratic equation. To have one root, b square minus 4ac has to be equal to 0. If there are no solutions, then what will happen? B square minus 4ac less than 0. Now fortunately we have two solutions. It means b square minus 4ac, if you look at that value, is greater than 0. And if it is equal to 0, then we can see only one repeated root, one root. And less than 0, uh, it means we can't find the solution because it doesn't intersect. So this is the equation. Circle, this is the line, and they are intersect at 2, 7. And quadratic equation is x square plus quadratic equation is x square plus 3x minus 10 equals 0. We'll draw this one. This is x square y minus 2 equal 29, right? So what is the center of this circle? Center is going to be 0 and 2. And r square is 29. R is square root 29. If it is 25, it's going to be 5. It means 5 something. So this is 0, 2. This is the center, 0, 2. And 2 plus 5, 7, somewhere. More than 7. It's going like this. Now, minus 5, 0 is here. And 2, 7, this is, okay. This is totally wrong. 0, 2 is in here. And more than 5. This is the circle. It will cut here at minus 5, 0. Cross out. Another point is 2, 7. 2, 7 somewhere. Yeah. So the curve, this is the line y equal x plus 5. So this intersection point is 0, 5. And this is 90 degrees. So this is the picture of this one. Now, what is the this equation? Y equal x square plus 3x minus 10. So this is a quadratic equation, and a greater than 0, it has a minimum, and the roots are x equal minus 5 and x equal 2. So I'm going to draw this curve now. So what else I need? What is x plus 3 over 2 square is going to be the symmetric line. So then 9 minus 3 over 9 minus 9 over 4 minus 10 minus 49 over 4. So then so symmetric line is going to be, this is 5, 3 over 2 mean 1.5 somewhere here. This is the symmetric line, x equal minus 3 over 2, and this graph, it has a minimum at minus 3 over 2 minus 49 over 4 somewhere here, and those are the root x equal minus 5 and x equal to, so this is the graph. This is y equal x square plus 3x minus 10. So now now just to show you that, so having roots for this equation, so this is the graph of x square plus 3x minus 10, and it has two roots for this graph, x equal minus 5 and x equal 2. And what will happen, the intersection point, the x value of intersection point is the same as the root of this x square plus 3x minus 10 curve. In other way, what you can tell about the root of this green curve, so here x equal to, and intersection x value of intersection point of this uh, line and a circle, which is 2. They are same. That's why we will tell that if there are two roots, then two intersection points, this one and this one. Unfortunately, this is overlap. This intersection point and a root is overlap, but that's fine. I'll pick up the example 8 in the book. This minimum is minus 3 over 2 minus 49 over 4. So what is the conclusion now? The conclusion is this. This is a circle, and if there are two intersection point, mean this green curve, I mean there are two roots for that. So if there is a one intersection point, mean there is only one root. So it is touching the curve, and there is no roots. Sorry, it's this situation. The circle and the line doesn't intersect, mean there is no roots for this quadratic equation. So that's what you need to know. So this is if there is a intersection point, two intersection point, b square minus 4ac greater than 0, and if it is 1, b square minus 4ac equal to 0, and if there is none, b square minus 4ac less than 0. So this is the summary basically. Also one more thing, you are deciding there are two intersection point by looking at this quadratic equation. If there are two root, then two intersection point. One root, then only one intersection point. Basically it is touching, it's become a tangent. And no roots mean no intersection. In other way, it is real. You want to see that whether there are intersection point exist or not with this the line and the circle, but we will check by looking at the quadratic equation. It is similar to something day to day, like uh, example, like if we have a problem in our body, we will take the temperature. Likewise, to check the intersection points, we check the quadratic equation and check how the number of roots, how many roots available for that quadratic equation. Real roots.